And each one has their own, the arithmetic and geometric both have their own things that you're looking at, their own types of patterns. All right, so a sequence is a list of numbers that follow a specific pattern. So we're going to be looking at two different kinds of notation. One's called a sub notation, where you see that little a and then a lowercase or subscript number or variable. So A1, A2, A3, and so on. And then there's also function notation. Now, function notation is what you're probably more used to from Algebra 1 and maybe geometry, but from last semester we used function notation, f of 1, f of 2, and so on. And so what that means is A1, A2, F1, F2, that just means the term number of the sequence. All right, so A1 means the first term of the sequence. A2 means the second term, and so on. Same with f of 1. It just means the first term of the sequence. So we can look at some examples of sequences here. This first example, 3, 7, 11, and 15. So 3 is the first term of the sequence, or we call that the A1 term. 7 is the second term, so we call that the A2 term, okay, second term, and so on. And so what we can do is go through this, this sequence and find what the pattern is, and then find the next term of the sequence. Right? So going from 3 to 7 to 11 to 15, what's the pattern? What are we doing to get from one term to the next? Everybody see it? Yeah. Yeah, adding 4, okay? So we can see to get from 3 to 7, we're adding 4, and so on. So that means to get the next term, or the fifth term, because there's 4 terms listed, to get the fifth term, we would just add 4 to 15, and so we can see the next term would be 19. And then we could get the next term if we wanted to. We would just add 4 to 19, get 23, right? So we can keep doing that to list out however many terms that we need in the sequence. All right, and then the second example, 2, 6, 18, 54. So 2 is the first term, so we call that the A1 term. 6 is the second term, A2 term, and so on. So what would the pattern be to get from 2 to 6 to 18 to 54? Yeah, okay, good. So hopefully everybody sees we're multiplying by 3. All right, so then to get the next term of this sequence, we could take the 54 and multiply by 3. And so what would that be? $162. All right, so the next term would be 162. And then if we want to find the next one, we can multiply by 3, and so on. All right, so this first example where we're adding the same number, this is called an arithmetic sequence. So an arithmetic, it looks like arithmetic, but it's pronounced arithmetic. That's a sequence where we're adding or subtracting to get from one term to the next. The second example, where we're multiplying by 3, anytime we're multiplying, that's called a geometric sequence. So anytime we're multiplying by the same number, it's a geometric. Now there's an infinite number of sequences out there in life. We're just concentrating on 2 specific ones, but there's others. I could give you another, sequence, and I'm sure that you could figure out what the pattern is and how to get from one term to the next. So let's see. How about if I gave you this? What would the next term be? Yeah, good. So what's special about these numbers? Uh-huh. Good. So you can see that there's actually 2 different patterns here. One is you can see to get from 1 to 4 we could add 3, and then from 4 to 9 we could add 5, and then 9 to 16 adding 7, 16 to 25 adding 9. So the next one we would add 11. Okay, that's one pattern. Okay, what's another pattern that you can see? Yeah.
It fills up 4 is 2 times 2, 3 is 9 is 3 times 3.
Good, good. These are all perfect squares, right? So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. So these are all perfect squares, so that's just another pattern, all right? There's cubes, so you could look at all cubes. Again, there's lots of different patterns, but we're, again, just going to be concentrating on 2 of them, the arithmetic and the geometric. All right, so let's go on. All right, so an arithmetic sequence is a sequence where between any two consecutive numbers, so two numbers that are right next to each other in the pattern, there's a common difference. So there's a difference between the two numbers that stay constant all the way through. All right, so to find this common difference, this value, we take any term in the sequence and subtract off the term directly in front of it. So this pattern says that if we take the A2 term, which is the second term, and subtract off the first term, A1, we get this common difference value. It's called the D value. Or we can take the third term in the sequence and subtract off the second term, and so on. So we can see that this first example that we did, 3, 7, 11, 15, 19, if we take any term in the sequence, so let's say we start with 7 and subtract off the one directly in front of it, 3, 7 minus 3 is going to get us 4. Or take 11 and subtract off 7. 11 minus 7 is also 4. So that 4 is the common difference. It's how you're getting from one term to the next. All right, so that D value is going to be really important in these sequences. So again, the pattern is, or the formula is, take any term in the sequence, subtract off the one in front of it. All right, so again, the pattern it says there is we're going to be adding or subtracting the same number to get from one term to the next. All right, so let's go through these examples here. It says identify whether the following are arithmetic. If it is, that's a yes or no question. So if it is, then state what that common difference is. Okay, what's the D value? All right, so in this first example, 4, -1, -6, -11, we want to first identify, is it an arithmetic sequence? If it is, then we want to find out what's the common difference, what's the pattern. All right, so you can just take your calculators if you want to. It's really easy, especially when there's positives and negatives or fractions or decimals. Take any term in the sequence, subtract off the one directly in front of it. All right, then see if that pattern continues all the way through. So let's say we take -1, subtract off 4. We get -5. So is the pattern subtracting 5 all the way through? Okay, and it has to stay consistent. If it skips and it doesn't, then it's not. Okay, but it's got to be subtracting 5 every single time. All right, so we could take and look, let's say we took -11, that's the fourth term, and subtract off the third term. Do we get the same answer? Well, yeah, we get -5 again. So because it stays consistent, it's -5, this is arithmetic, and the D value is -5. All right, now some sequences you could just look at it real quick and see what the pattern is if you're adding the same number or subtracting the same number. Others are a little bit more difficult, like I said. So on number 2, is it arithmetic? Are we adding or subtracting the same number to get from one term to the next? No, because to get from 3 to 5, we're adding 2. Okay, so you can see we're adding 2 here, but to get from 5 to 9, you'd have to add 4. And as soon as it skips like that, it doesn't stay consistent, it's not arithmetic. So because it's not arithmetic, that means there is no D value. There's no common difference. Okay, there is a pattern here, but it's not an arithmetic pattern. We're only looking for arithmetic patterns. All right, number 3, 1.5, 4, 6.5, 9. Is this arithmetic? Okay, so to get from 1.5 to 4, you'd have to do what? Add 2.5, right? So now we want to see if we take 4 and add 2.5, we're going to get 6.5, which is in our sequence. So we take 6.5 and add 2.5, it's 9. And so it stays consistent. So yes, this is arithmetic. And the D value is 2.5. Okay, again, if you had calculators, the calculator will do it all for you. You don't have to really even think about it. Just take 4, plug it in your calculator, minus 1.5 equals 2.5. Then take another term in the sequence and subtract off the one in front of it and see if you get the same thing. All right, number 4. 8/3, 7/3, 2, 5/3. Right? Well, I know to get from 8/3 to 7/3, I would have to do what? Subtract 1/3, right? Again, your calculators, just put in 7/3 minus 8/3, negative 1/3. Right? So now we want to see, do we get the same answer? Let's say I took 5/3 and subtract off 2. Okay, again, your calculators will do it all for you, but if not, you need a common denominator, which would be 3, so you'd have to multiply top and bottom by 3. So then this is 6/3. So 5/3 minus 6/3 is negative 1/3. It's the same answer, so that means it is arithmetic, and the d value is negative 1/3. All right. So you should definitely try to use calculators. I'm telling you right now, it's going to make it a lot easier. All right, so let's keep going. All right, so now what we want to do is, it says write the first 5 terms of the sequence. Okay, and it's telling us it's arithmetic. So that means that we have to be adding or subtracting the same number to get from one term to the next. So they give us a1 equals 6 and d equals negative 2. So that means that our first term of the sequence is 6, because that's what a1 means. So we're going to start with 6. Then they give us the d value. They're telling us to subtract 2 each time. And so now we just keep subtracting 2. So we start with 6, subtract 2. So that means the next term is 4. And we want to subtract 2 again. So we're at 2. Subtract 2 again, 0. And then one more time, negative 2. So that's the first 5 terms of the sequence, where the first term is 6, and the common difference is negative 2. All right, number 6, they give us f of 1 equals 3. That means the first term is 3. They give us f of 2 equals 7, so that means the second term is 7. All right, so that means that we have to find the next 3 terms. Because they're telling us it's arithmetic, that means that we have to be adding or subtracting to get from one term to the next. So to get from 3 to 7, we would have to add 4. So we'll take 7, add 4, that's 11. Add 4, 15. Add 4, 19. All right, now number 7 is a little different. This is, when it's written this way, this is called a formula or a rule. We call this the AN rule because there's an A and a subscript N. So when they give us a rule to find the first term, what we're going to do is plug 1 in for N. So wherever there's an N, you can put 1 there. And then we simplify it. So A1 equals 2 plus 5 is going to be 7. So here we know that the first term is 7. Well, I can find the second term by plugging 2 in for all the n's then. So I take my formula again. A2 equals 2 times 2 plus 5. So that means the second term is 4 plus 5, which is 9. Well, now that I know what the first 2 terms are, I should be able to see what the pattern is and then get the next 3 terms to get all 5. All right, so the first term is 7. I'll just do it over here because I'm running out of room. The second term is 9. I can see I'm adding 2 each time. So the next term would be 11, 13, and 15. All right, number 8. Given the arithmetic sequence, 4, blank, negative 6, negative 11, and blank, what would the second and fifth terms be? So we have the first term, we have the third and the fourth. So what would the second term have to be then? Yes?
-1.
Okay. So we can see to get from -6 to -11, we're going to have to do -11 minus -6, which is going to be -5. So we're subtracting 5 each time. So that means that the d value or common difference is -5. I'm just going to keep subtracting 5. So then what would the A5 term be? -16. Good. All right? So to get from -11 to the last term or the next term, we would subtract 5, and so that's -16. All right, so then to write what's called an explicit formula, so our rule, we're going to use this little formula here. AN equals A1 plus N minus 1 times D. So the A1 is the first term of the sequence. And then the D is the common difference. Those are the only two things you need. And we can substitute those in, the A1 place and the D place. And then we can distribute the D value into the parentheses, N minus 1, and then we collect like terms. What we're trying to do is get it into the form of y equals mx plus b. We're just changing the y and the x to an and n. That's the only thing that's different, which is the slope-intercept form. All right, so you'll see what I'm talking about on how we can use this formula to simplify it down. All right, so we're going to write an explicit formula. It says for the nth term, that just means that we want n's in our answer. So an and n in our formula. So our sequence is 1, 4, 7, and 10. So the first thing we want to do is find the common difference. So to get from 1 to 4 to 7 to 10, we can see that we're adding 3. So our d value is 3. Our a1 term is 1, the first term. So we're going to take those two values and plug it into this formula. So an equals 1 plus parentheses n minus 1 times the d value, which is 3. So that's the first step. Just plug those two numbers into their respective places. Now we're going to distribute the d value into the parentheses and then collect like terms. So 1 plus 3n minus 3, that's just distributing the 3 in. Now we can collect like terms, so the first and last terms can be combined. So an equals 3n minus 2. And so that's the simplified version, or we call this the explicit formula for this sequence. It doesn't matter if you write 3n minus 2 or -2 plus 3n. I don't care. You'll see both ways written. When I do it, I usually put it in that mx plus b form. All right, so you can see it right here, mx plus b. That's basically what this is, mx plus b. They just changed the lettering around. That's all. So instead of x's and y's, it's an and n. All right, so let's try 10. All right, so the A1 term we can see is 6, and the common difference, the d value, we're subtracting 4. So we'll substitute those two numbers in. So an equals 6 plus n minus 1 times -4. And we're going to distribute the -4n. So 6 minus 4n plus 4. And then just combine like terms. -4n plus 10. All right, so now what we're going to do is the exact same thing. We're going to write an explicit formula, a rule, for this sequence that's given. Then we're going to take that rule and we're going to find the 20th term. So once we have our rule, we can plug 20 in for n, and then just use order of operations to find the 20th term. So this rule allows us to find a certain term in the sequence without having to write out all 20 terms. That would take a long time. All right, so we're going to do the exact same thing as before. So we can see the common difference is we're subtracting 5. And the A1 term is 7. So 7 plus n minus 1 times negative 5. We're going to distribute. Uh, 7 minus 5n plus 5 will collect like terms. Negative 5n plus 12. Now we're going to use that and find the 20th term. So we're going to write a sub 20 equals negative 5 times 20 plus 12. Okay, so you're just plugging 20 in for n. Order of operations, calculators, whatever you need. All right, so negative 5 times 20 is negative 100 plus 12, negative 88. All right, so the 20th term is negative 88. All right, so see if you can do number 12. So the steps are the same. So solving for y, we're going to get 3x minus 4. Now we're just going to replace the letters. So y becomes a sub n, and x becomes n. So we have the explicit formula an equals 3n minus 4. Now we can find the 15th term by plugging 15 in for n. So a sub 15, I already have that. 3 times 15 minus 4. And we just simplify it down. 3 times 15 is 45, minus 4 is 41. So the 15th term, a sub 15, would be 41. All right, so let's do this last one, number 14, same thing. Since the two terms they give us, A4 and A8, are not next to each other, we can't just find the common difference by looking at a pattern. We're going to treat these as ordered pairs. So 4 comma 19 and 8 comma negative 1. We're going to use the slope formula. Subtract the y's, put them on top, negative 1 minus 19. Subtract the x's, put them on the bottom, 8 minus 4. Simplify this down, negative 20 over 4, so it's negative 5. So when you do this, if you do it right, you shouldn't end up with a fraction. I make these nice for you guys, because I know this is probably the hardest problem out of the whole, I would say probably the whole unit 6, these kind of problems right here, because there's lots of formulas that you have to use in the right order to answer the question, right? So it'll work out nice, like it is. All right, so we have the slope. Now we're going to pick one of the 2 points. Again, it doesn't matter which one you use. Here I'll just use 8, negative 1. So this is the point slope form that we're using now. So y minus negative 1 equals negative 5, which is the slope, x minus 8. We have a double negative there. We'll distribute. negative 5x plus 40. And then subtract the 1. Negative 5x plus 39. All right, now we'll just replace y with an and x with n. So there's our explicit formula. Now we can find the 15th term by plugging 15 in for n. All right, so negative 5 times 15 plus 39. And use calculators, easier. Negative 5 times 15 is negative 75 plus 39 is negative 36. So the 15th term, or a sub 15, is negative 36. All right, so that's all we're going to do for today. That's